This is Mr. Beck Does Your Homework. This is AP Physics Homework 7.3, question number 8. A liquid of density 1,295 kilograms per meters cubed, those are standard units, flows with speed of 1.91 meters per second, standard units, into a pipe of diameter 0.29 meters. That's a diameter, so be careful. The diameter of the pipe decreases to 0.05 meters at its exit end. The exit end of the pipe is 5.22 meters lower than the entrance of the pipe. And the pressure at the exit end of the pipe is 1 atmosphere, which we know that 1 atmosphere is 1.013 times 10 to the 5th, which is my 101/300. Applying Bernoulli's principle, what is the pressure P1 at the entrance end of the pipe? Assume the viscosity is negligible, fluid is incompressible, and G is 9.8. So what I need here is Bernoulli's equation, so that tells me my P1 plus rho G H1 plus 1/2 rho V1 squared is going to equal my P2 plus rho G H2 plus 1/2 rho V2 squared. What of this do I know? I'm looking for P1, so I'm searching for P1. My height here is 5.22 meters, my G is 9.8, and my density is 1295. So I've got 1295 for my density, I've got a G of 9.8, and I've got a height of 5.22 meters. So that's this gravity term. 1/2 rho V1 squared, let's see. So that's going to be 1/2. The density, again, is 1295. And my initial velocity is 1.91 meters per second. So these are two terms that I know everything about. That's going to equal, let me just continue it here, P2, well, my pressure 2 is 1 atmosphere. So that is 1 atmosphere, and that's 1 times 1.013 times 10 to the 5th. That's my P2. Plus my rho GH, my density is 1295 times 9.8 times, a height of 0. So this term actually goes away. Plus 1/2 the density, 1/2 rho V squared. So that's 1/2 of 1295 times V2 squared. Well, I've got to solve for V2 before I can plug this in. So now I know just to plug in my V2, so I'll leave that a blank here. To get my V2, I know that my area 1 times my velocity 1 is going to equal my area 2 times my velocity 2. Area 1 is going to be pi R1 squared times V1 equals area 2 pi R2 squared times V2. Conveniently, pi is on both sides. Now my radius 1 is going to be half of my diameter. So this is going to be d1 over 2 parentheses squared times V1 equals d2 over 2 parentheses squared times V2. Well, also I've got this divided by 2 squared divided by 2 squared, so this actually goes away. So I've got d1 squared V1 equals d2 squared V2. So if I want to solve for V2, I can square this times my initial velocity, and then I'll get my new diameter, square that, and divide over here to get V2. So now I can solve for V2 and plug V2 in there, and then you know that, and you're looking for this one. So now you can solve for P1. And this will give you an answer in pascals.